Hello again. It's been a few days. I've been busy trying to get reflective mapping working, and here's the demo that demonstrates it. Now, en- reflective mapping or environmental mapping is a technique that basically uses cube mapping in order to produce reflections. Um, most implementations of environmental mapping are usually static. However, my objective for this implementation is to be dynamic, to do dynamic reflections. So let's look at the test scene. To achieve dynamic cube mapping, you need to use OpenGL object known as an FBO, and you basically record information to a cube map, which what that is a six face texture that you can render to each face on. The problem with it, well, there's not really any problems. I'm out of it like I was a few days ago. I was up all night working on this. Um, yeah, the biggest issue with this implementation is that you have to render to each face, so it's a 7-pass system. So let's look at this scene. Well, you don't see any reflections yet. Well, the reason why that is that I made it where you can blend the reflection or whatever the QMAP is seeing with a certain simple constant. You can just change it back if you want to change the level of reflectability. Um, Also, this object can have different colors as well. Let's see, white, black, red, blue, nice little color, yellow, magenta, cyan. This is gold. An attempt at silver, but oh well. And bronze. Let's keep it with blue because that looks. I like blue. As you can see, it renders the entire scene fairly seamlessly. There's no mess up with it. Another thing you can do in environmental mapping is known as refracting, which is this. It allows you to see through an object, and it looks pretty cool. I have it where it's I guess concaving. Yeah, it's concaving. You can also combine each effect together to form a glass-looking object. Yeah, it looks pretty cool. Now, the only problem I see with this is that the only way to increase the finite detail on an object is to increase its how many vertices there are, because it's reflecting off the normals in order to produce this effect. Wait a minute. That means that you can also utilize bump mapping or normal mapping. Let's take the specularity down real quick. Y'all should know that bump mapping is a technique to give a shape some bumps. It basically messes with the specular lighting and diffuse lighting in the scene. This means because you're utilizing the normal, you can do this in the fragment shader to reduce reflections. As you can see, it scatters the surface in different directions because I'm using tangent space. And it looks pretty cool. This can also be applied to refracting to give it a more translucent look instead of just being entirely see-through. There's some sort of filter in front of the object, and it makes it look pretty cool. And let's apply the and you can also apply the reflective thing. Oh well, this is dynamic Cubemapping. It's pretty useful. I would say this particular implementation is pretty expensive because you're doing 7 passes. There's a another way to reduce cube maps and then reflect to them in one pass using the geometry shader in OpenGL 3 and DirectX 3D11, which I'm not going to use right now because I'm just focused on trying to learn just basic stuff at the moment. The next thing I'm going to work on is implement parallax occlusion, which adds depth to a bump map. I probably will have that out in a few days. Well, I guess this is it for now. You all take care. Let's change this to the most annoying color ever made, magenta. Yeah, it's so annoying. It's so ugly. Oh, y'all take it easy.